morning. My name is Ron Gupta, and I'm the program chair for Pan IIT 2000 conference. It's my great honor to welcome you all to this session. And it's really indeed an honor to have General James here and Bob Balram, IIT Madras graduate, and of course, Gunjan, who's going to moderate this show. I'm only going to talk for just a few seconds, first to just introduce a little bit about what I did for NASA like 45 years ago, and then introduce Gunjan. When I was a little kid, I'm going to say a little kid, about 24 years old, I came out of college, Carnegie Mellon, started working with an engineering and architectural company in Florida. And my first assignment was to design a structure for ALT at that time, which is approach and landing test for the space shuttle. At that time, we didn't have computers. So I used matchsticks to create a model of a building, of a structure that would lift the space shuttle up and put it on top of a 747 so that it could fly across the continent. And as a result of that, I did get an award from the astronauts at that time, Fullerton, Engel, Tooley, and Heiss. I'm sure you remember those names. And so that was a very excellent quality work to be done at such a young age. At this time, let me introduce Gunjan. Gunjan is a proud Pan IITian. He was the president and chairman of Pan IIT USA. He's a graduate of IIT Kanpur, and presently he is CEO of Emirates Corporation. So Gunjan, take it from here. Thank you.
Thank you so much, Ron. Really appreciate this. And this is going to be a fun discussion looking at the work coming out of the Jet Propulsion Labs, which is a NASA lab. And we have two fascinating speakers. I did want to alert the audience that the polls are active. So if you are online, please go take a look at the polls and answer the questions that we have put up there. We'd like to know a little bit more about you. I think there's 4 questions. And we are in Hollywood here in Southern California. So at least one of the questions has to be about a movie. And I will ask both of our speakers that question as well. So please take a few moments to look at that. Now, many of you might have attended the keynote speech by Prime Minister Narendra Modi yesterday. And he had only 15 minutes to talk, but I am so glad that he put in a plug for our session because he mentioned space technology and space startups in India. And then he quoted from one of our favorite shows talking about going boldly where no one has gone before, which you will hear plenty about in this session. You might also know, some of you in the audience, that the topic we are going to talk about now is not the first time these things are happening. When ISRO launched the Chandrayaan mission a few years ago, aboard that moon mission were 2 American experiments. And JPL, Jet Propulsion Labs, had something to do with at least one of them. And that led to the discovery of water on the moon. So the collaboration between India and the United States has been going on for a while, but we are going to talk about 2 very new and very interesting things, one which has an IIT angle and one which has an ISRO angle. Let me start with the ISRO angle. And about 3 years ago, I was speaking at an event called Select Los Angeles, organized by the mayor of Los Angeles. And one of the other speakers at that session was General Larry James, who I think had just returned or was just getting ready to go to India to discuss the very thing we are going to talk about today. So we struck up a short conversation, and then I remembered that when we had this Pan IIT discussion, and General James has been kind enough to give us some of his time today. Larry James is an aerospace engineer, and then went on to get his master's degree at MIT. Uh, he was with the US Air Force for a number of years. And at the time of his retirement, he had 20,000 people at the Air Force working under his organization, having to do with ISR. And let me see if I can recall exactly what ISR stands for. Larry, can you help me out?
Intelligence, surveillance, and reconnaissance.
I forgot about intelligence. You know, I left my intelligence at IIT. So it's great that you have an MIT connection, because I'm a graduate of IIT Kanpur, and IIT Kanpur was set up by MIT and Caltech. And Caltech, of course, runs NASA's Jet Propulsion Labs. So we have a good connection there. I'm going to turn, let's see if the polls have produced any results yet. Can you share the poll results if they're coming in? I guess our tech team is still working on that, so we can start with the slides. So Larry, what I'd like to do is have you run through the slides fairly quickly, and then we can get into our Q&A session right away. So let me bring those up.
All right, Gunjan, well, thank you. Thank you for the introduction. And again, thank you for the opportunity to be here this morning. It's certainly a privilege for me to speak to this large group that is focused on IIT in India, and really all that's going on in India with science and technology, and in particular for me, space. Just a little bit of background. I've been to India multiple times now in support of the NISAR program, everywhere from Bangalore to Ahmedabad to Trivandrum to Delhi to Chennai, et cetera. Just really in support of our growing relationship and in support of this particular project, which is an absolutely essential project for both, I think, NASA and ISRO. So we just go to the next slide. I'll just give you a little bit of background on NISAR. Many of you know about that particular mission, but I wanted to highlight some of the key things and key areas, because it really is a very strong partnership, you know, an equal partnership. And Gunjan, if you could flip to the next slide, mine's not moving. I don't know if, there we go. So just kind of highlighting how we put the work together. First of all, this is a synthetic aperture radar. It's a swept synthetic aperture radar. So the beam digitally sweeps across the surface of the Earth. It operates in two bands, L band and S band. L band, as you can see there in the green, provided by JPL, and S band in the red, provided by ISRO. ISRO is providing the bus, the satellite bus that we will put all of these payloads onto, and then the radar instrument suite, which is a key component that JPL is putting together. So the S band electronics will come to JPL. We'll install the instrument suite and put it all together there to create the payload. We're also providing the large deployed radar antenna, as you can see, 12 meters. So I think this is the largest swept SAR antenna that we've ever put up in space. And of course, the boom itself to deploy the antenna. So that's kind of a picture of the work share. And of course, as you see on the left, ISRO is providing the launch vehicle going from your launch site there in the Southeast India on the GSLV Mark II. So we're very excited about that as well. To be honest, I haven't been to the launch site yet, so I hope to be able to get to go there when we launch in early 2023. So that's just a little bit of background. The intent is to really examine the Earth from a polar orbit. And we kind of have the tagline, you know, studying the Earth in motion. And certainly, Gunjan, we can get into more details on that as we get into the questions. But you can see the ISRO centers that are involved really split across almost every key center for ISRO. Next slide. And again, I just wanted to highlight some pictures here, just showing you the cooperation. You can see on the right side, the S-band SAR radar electronics and system test at Ahmedabad. So a very important milestone for the program. That payload should be delivered to JPL here very soon. And then on the left is the L-band SAR system being constructed at JPL and going into the vacuum chamber. We've completed our environmental testing on that component. So everything is moving along very well, and we're about to reach the point where we get all the components together and start integrating the payload. Next slide. And this is just really to point out that this is an incredible team. Obviously, this is JPL and really NASA's first major partnership with India on a major spacecraft program. So of course, there's a lot of learning that goes along, plus just figuring out how do you operate when you're essentially 12 and a half hours separated from each other. When do you have your meetings? It's long flight time to go to India. So just working out all of those details has been a learning experience, I think, for both teams. But I would say now we are a well-oiled machine in terms of integrating, working together, and really bringing this whole spacecraft together to support the needs of both the United States and the world and India. So that's kind of what I wanted to end on in terms of just pointing out that it is a great team. We've been working together, and it's coming together well with the payload coming together here early next year. So with that, we can go into kind of the Q&A there, Gunjan, and go from there.
Thank you so much, Larry, for that great overview. And I do want to mention to the audience again, please keep sending us your questions. I haven't seen them on my side yet. So this will be as interactive as the audience wants to make it. Also for the tech team, let us know when you can show the polls. Let's get going with our Q&A, General James. So first of all, tell us a little bit about the budget of this program of NISAR or NISAR.
Yeah, on the NASA side, it's about $900 million. And on the ISRO side, I don't have all the exact numbers, but I would say in terms of the spacecraft, probably about 300 million in US dollar equivalents. And one point I would certainly make is that, you know, this is a mission that has been a high priority for the United States. And if you're familiar with how we do science, we have decadal surveys that define what are the priorities of the missions. And this has been a very high priority for many, many years. And frankly, NASA could never receive the funding to put this project together. So the ability for both of our nations to come together, fund their portion of the program, is really what allowed us to get this project going and get it launched. And it really goes back to 2011. Alok Chatterjee, who is a graduate of IIT, currently works at JPL, originally started at the Satish Dhawan Center there, but has really been at JPL over 30 years. He has really kind of been working this since 2011 to bring this team together, get all the agreements in place and so on. So shout out to him as well for the great work he's done. And he continues to be the primary interface for the NISAR project with ISRO.
Right, right. I know Alok well, and he's a graduate of IIT Kharagpur, and you know he's spoken passionately about the programs that he's been involved with, having worked both at ISRO and JPL.
Yes.
I think that's a wonderful person to have on your team.
Absolutely.
So one thing I just want to make clear to the audience is that this is not simply a matter of JPL outsourcing some work to ISRO. This is really a collaboration of equals where both parties have certain responsibilities to make this happen. As an IIT, and I'm very proud of the work that IITians have done, but I do want to recognize that most of the engineers working today at ISRO are not graduates of the IITs. And a shout out to all of them as well in contributing to India's leadership in the space program. And I'm hoping we can see our poll results. I'm really curious to see how many people have joined in who are not IIT alumni. As IIT alumni, we put together the program, but it's really open to all, both in the US and in India. Now, I want to explain to the audience a little bit about what this satellite is going to do. I understand it's the most expensive Earth observation satellite ever to be planned, and probably the most sophisticated. So it has so many different goals. General James, I tried to study that, and I was reminded of my years as a student, but I think it'll take weeks to really understand everything. So I'd just like to check off a few items to clarify. So many of the satellites that people benefit from every day are geosynchronous satellites launched 23,000 miles above the Earth, and they stay over the equator at a stationary point. This one is almost the exact opposite, right? You're almost in a polar orbit. So just tell
Right.
us a little bit about what polar orbit and sun synchronous orbit, what does that mean?
Yeah. So if you want to be getting a view of the entire globe, and I think if you've been in the space business, you understand this, you want to be going over the poles because you're in an inertially stable orbit, but the Earth is rotating beneath you. So as the Earth rotates, you get a different view of the Earth every time you go around, about every 90 to 100 minutes. So that's the reason for the low Earth orbiters, we go into a polar orbit from a weather or Earth science perspective. You want to look at the entire globe. So we, as you said, we're about 750 kilometers up. Obviously, the closer you are to the Earth, the better resolution you would get with radars or cameras or whatever. So you want to be reasonably close to get the best resolution. And then we're in that 98-degree orbit, which again, essentially gets us entire Earth coverage. And the way it's designed, we cover the entire Earth every 12 days. So every 12 days, we're mapping the Earth with our L-band and S-band radar. We get a great picture of that. And then what we do is we fly over the same location and essentially use radar interferometry to see what has changed from the time we last flew over to the time that we are currently flying over. And when you're using interferometry, that allows you to get very, very precise measurements of what has changed. Has the Earth moved? Has the foliage changed in content or mass? And for movement, you're talking down to centimeters and sometimes millimeters in terms of the ability to measure change. So that is the power of the synthetic aperture radar, doing a repeat orbit and then combining those two measurements every 12 days to see what has changed. So that's why we fly at the lower altitude in the polar orbit versus the geosynchronous, where you're looking at one space, and that's where the weather satellites fly. They're always looking at, for example, the Western Hemisphere or whatever to say what's going on from a weather perspective. But we want to have much more precise measurement.
Got it. Okay. Now I noticed that ISRO has two different launch vehicles. One is called the PSLV, the Polar Satellite Launch Vehicle, and the other is the GSLV. So my thought would be that they would use the PSLV to launch something into polar orbit. So, as IITians, we look for these, these apparent paradoxes, and it seems that they are using the GSLV Mark II. Mark II, I guess, because it doesn't involve any prohibited technology. That part I understand, but why are they using the geosynchronous launch vehicle?
My understanding is just mass. The GSLV has more throw capacity, and this is a big spacecraft. So, you can launch on any azimuth you want to, whether you're a PSLV or a GSLV coming out of the launch site, but it's really mass. Okay. And so the GSLV had the capability to get this very large spacecraft up into orbit.
And very large and very heavy, I think translates to what, about 2.5 tons, if I remember right?
I believe you're right. Yeah. It's a pretty big machine.
Okay. Well, our audience is putting up a number of questions. I'm going to select some of them. First of all, when will we see NISAR in orbit?
Right now, early 2023. So
2023.
As you might imagine, we originally had a launch date earlier in that, but the COVID pandemic really impacted all of us. Sure, we had to stop work at JPL. I know ISRO had to stop work working on the S-band system. Right. And so we've recovered from that. I think we're still not as efficient as we would like to be in terms of the work going forward, just because we can't have everyone that we would like to have working in the space we would like to have them working in, given the COVID restrictions. But right now, I mean, if everything was perfect, it could be late 2022, but we're kind of saying early 2023.
Got it. Okay. Can you tell us a little bit about the specific benefits that will come to humanity from this? And let me just pick a couple of areas. Here in Southern California, we are under severe threat of fires at this moment because of the Santa Ana winds and the very dry conditions. Can you tell us a little bit about how the work of NISAR will help in that regard in terms of forest cover and fires and so on?
Yeah, again, you've got a radar, both L-band and S-band. And again, this is the first swept SAR L-band, S-band, dual band spacecraft. And I talked about biomass. So I would equate that to understanding what's happening with the fires, because with the L-band and S-band, we can look at biomass, how, let's say foliage, how much the forest is compacted and full. And if you have a fire, that's obviously going to be reduced. And so we can get a pretty rapid picture of the devastation caused by a fire, for example, because that biomass has changed. Suddenly, instead of thousands and hundreds of thousands of trees, I may have lost 30% of them or 40%. And now I can get from space a very clear picture of the devastation caused by a fire. And then that will help us to manage how we recover from that.
I see, great. So one area that I think is a shared concern for both the United States and particularly California and India is the impact of earthquakes. Here in California, we live in a seismically active zone, and much of India, particularly North India, is subject to earthquakes as well. And there's been a tremendous amount of construction in the last 20 years, and India hasn't seen a 7-point-something earthquake, in a while. So can you tell us a little bit about how NISAR will play a role in terms of seismic activity and monitoring that?
Sure. As I said, kind of our tagline is Earth in Motion.
Yeah.
So obviously, as you all know, we all sit on tectonic plates and the Earth is constantly moving. And again, with the interferometric measurements, you can measure down to very fine grained detail. So one of the things that NISAR will give us the ability to do is see the motion of the surface of the Earth at very fine levels, centimeters, potentially millimeters. And that's helpful for the geologist to understand what's going on with the movement of these plates. So for us, for example, in California, the San Andreas Fault, how much is the Earth moving? Certainly we have ground-based systems as well with GPS that are measuring that in certain areas. But if you want a global look, NISAR is going to allow us to do that. So I think that's point one in terms of just understanding what's happening. Do we see rapid movement that we didn't have before? Could that be an indicator? And again, earthquake prediction is kind of black magic these days. You can't really do it very well, but at least understanding the precursors is an important thing. And then if there is an earthquake, understanding how the Earth did move, also being able to map major areas of devastation based on the change that we measure with the L-band and S-band radar and the interferometry. And that will aid disaster response also. So both those, I think, are important to both the US, California in particular, and India as well.
Got it. Okay. Now the two different bands, L-band and S-band, are being designed, one in the US, one in India. So will they be controlled by their respective organizations, or will the US have access to India's radar and vice versa?
Yes, India will be operating the spacecraft and the data coming down. They were primarily going to downlink the S-band into the India area, of course, and then the US will downlink the L-band for their purposes, but there will be joint access to this data. And this is a global good, really. And so certainly the S-band, from an Indian perspective, they're going to focus most of their measurements on the Indian subcontinent and a few other areas that they're interested in. The L-band will focus globally. We'll measure globally all these changes. But so you really do have two powerful regimes that will be operating, but the data will absolutely be shared. And there's multiple, India has a downlink site. We have downlink sites that are handling these, frankly, large quantities of data, like 43 terabytes of data per day that we have.
43 terabytes per day. Wow.
Yeah.
Okay.
So this is a, you talk about big data and being able to manage that. This is a challenge. This is one of the challenges we've had to deal with in terms of just designing the onboard telemetry and downlink system and the ground system and the ability to handle all the data.
Well, later on, we are going to talk to Bob Balaram, who's sending something to Mars, and let's see how many terabytes of data he can get in a day from Mars.
It's not terabytes from Mars, I'll tell you that.
Yeah, exactly. one of the questions that has come up, and I want to preface that a little bit. I know many IITians who used to work at JPL, developed some great technology, and then have gone out and built their own companies in the areas of batteries. I know somebody has done that in the area of data and some GPS related work and crypto and so on. So one of the questions is about the kind of startups that that might be spawned by the data that is gathered by NISAR. Uh, can you give us a little bit of a glimpse of, what could be possible?
Yeah, I mean, again, this is a unique data set with respect to global measurement of Earth change. And, I don't know, I'm sure there's people thinking about it out there, but I think there's going to be a variety of opportunities to take this data and, let's take biomass. I mean, if I can measure biomass very accurately and globally, I think there's value in that, whether it's for agricultural management, whether it's for farm management. So, I mean, there's just a whole host of things I think that data can be used for, and that things that we haven't even thought of yet. But once the data is there and accessible, then it's developing the analytics and the tools to do something with it that, frankly, at the end of the day, you make money on.
Got it. Okay. Now, you used to work for the US Air Force for much of your career, and I know that there is tremendous military collaboration that is happening between the US and India today. But from what I understand, this project here is a purely civilian project, right? There's no defense or military considerations to this at all, right?
Right. I mean, it's, in the US, the Civil Space Agency, NASA, is totally separate by law from, Air Force space operations and DoD space operations and so on. So we're totally separate now. I mean, obviously, this is very useful data for a variety of purposes. So there could be military utility in the data, just to understand, again, if I'm looking at a particular area, I'd like to know as much about that area as I can from a military perspective. Then this data can be useful, but this is a purely civilian program.
Right. Okay. Just looking at the audience questions to see if there's something we haven't covered yet. Are there future programs planned in terms of collaboration between ISRO and NASA that you can mention briefly?
I would just say that we're absolutely actively working in that arena. I've met with Chairman Savan many times, and I know our Office of International Relations at NASA is continuing to have dialogue. There's ongoing dialogues that happen. I know India, we're having dialogue now in terms of signing the Artemis Accords, which is the accords about our mission to the moon, the manned mission to the moon, and for Earth science perspective, as I said earlier, the decadal survey that we do in the U.S. defines kind of the next 10 years, the priorities that we should look at for Earth science. And one of those priorities is essentially a follow-on to NISAR. It's taking that set of measurements and trying to develop them further, improve, bring new technology, and so on. So, I mean, there's no guarantee that would end up being a partnership with India, but we need to look at those things and say, yes, there's absolutely opportunity out there, and there's absolutely dialogue going on about what those could be.
Got it. Okay. Are there a number of IITians working at JPL that you're aware of beyond Alok?
I would say right now there's between 10 and 20 that I'm aware of that have graduated from IIT and come to JPL. As you said, some have come and gone and done other things, but just a very strong relationship. And you mentioned Caltech. There's a great presentation that Caltech does about the relationship with Caltech and India and IIT back to the 30s, where some of the professors were over in India doing gamma ray experiments with balloons. And so just a very historical, long-term collaboration. And we actually have an intern program with IIST, where we bring 2 interns from IIST to Caltech every year to get their master's degree. And then they do a summer internship at JPL. And so we're trying to build those relationships, build that knowledge of one another. And I envision that, frankly, in the future, there will be more folks from IIT here at JPL.
Got it. Okay. So, I mean, my day job is helping Americans to deal with India. And, in fact, I used to teach a workshop at Caltech on doing business in India. So hearing you talk about the challenges of the time zones and the cultures is very interesting to me personally. Um, if there are students listening to this talk, and students from India in particular, do you think there may be room for somebody from there to think about a career at NASA or at JPL?
Of course, of course. I mean, Alok is a great example, right? I know 10 or 12 years in India and Israel, and then came to the US and started working at JPL. So
Yeah.
We are a very diverse and globally diverse organization at JPL. We have people from France, people from Australia, people from India, people from Great Britain, people from Germany that work at JPL. So it's just, what are the skill sets you have? What are the needs that we have? And frankly, are you in the top tier? Because those, we have about 6,000 folks that work here, and it's a very competitive environment to come. But I will tell you that the Indian students that come from IIST to Caltech, I think last year, 2 years ago, the master's degree student was the top student there. So you're doing very well.
Great, great. So let me ask one final question. As I alluded earlier, what is your favorite space movie?
I would probably have to, probably not too exciting, but I'd go back to the first Star Wars movie. I mean, this was, I was, it came out, I was at the Air Force Academy. It was very inspiring. I loved space, and it just kind of gave you this excitement about space that with the visuals that had never been done, that no one had done before. And it was certainly at a very formative time of my life. So I'd go back to the first Star Wars movie.
Awesome, awesome, wonderful. I did watch that movie. It came to India back in those days. It took 3 years for a movie to show up in India, and I was working in Bangalore at that time. I just graduated from IIT Kanpur, and I got to see Star Wars, the very first one. Yeah, so I have good memories of it. So thank you so much, General James, and thanks for offering to stay on through the rest of the session in case other questions come up.
Sure.
The tech team is having a little bit of an issue with the polls, so we are going to have to do without the polls. Let me now turn to Dr. Bob Balaram. And Bob, let me turn this backwards and start with what is your favorite space movie?
Okay, yeah, even though it had a very major technical flaw, it's probably The Martian. I think that's an example of problem solving that is very much an engineer's dream. So that was probably my favorite, even though for dramatic reasons, they had a very significant technical flaw, which is that Martian storms would, be that destructive, which they aren't. But other than that small detail, just from a purely technical perspective, it was warmed my heart to see, all the problem-solving approaches and building of systems that got him out of there.
And Bob, I would just make a quick comment because I've talked to Andy Weir, who's the author, and he knew that the storm could not do that, but he said I had to have a plot device that would start the problem. So that's what I used, even though I knew the atmosphere would never topple the rocket. So
right, and I think
that he didn't get it right.
Yes, and every movie I think is allowed one, free pass on something like that in order to. So as long as it's not so many that you sort of say this is not real. So they picked that one, but everything else after that was so well done for me, and it's an engineer's movie, and it was also a very good movie otherwise too.
Yeah, so I can imagine 10 years from now, because it takes Hollywood 10 years to make a good movie of this kind, that we will see a movie that talks about a flight to Mars, and Bob will be piloting a helicopter that goes from, takes off from JPL and lands on Mars. I've already seen some flow of information on this Pan IIT thread that's talking about a helicopter that's already flying to Mars. So let's set that straight a little bit. The helicopter is indeed on its way to Mars, but it's not flying to Mars. It's attached to the belly of the spacecraft and will actually be dropped on the planet sometime in February, and then we will see Bob's magic start to happen. Is that an
Correct. Yeah.
accurate summation, or did I take too many liberties there,
No,
Bob?
no, we are a stowaway on the Mars Perseverance mission, which is a very exciting Mars JPL mission to look for, uh, evidence of life and collect samples for eventual return. And out of that very large flagship mission that NASA is flying, they have been kind enough to let us stow away as a technology demonstration.
Right.
And they're going to give us 30 precious days on their calendar to allow us to do our technology experiment on Mars. You got that right. Yes.
So it's interesting that we are talking about it in this week because the big space news this week has actually come out of China, where the spacecraft that they landed on the surface of the moon is picked up samples and is flying back to Earth. So let me start with that question first. Do you think there's a possibility sometime in the future, in the relatively predictable future, that we'll be able to bring samples back from Mars to Earth?
Oh, yes, very definitely. The Mars Perseverance mission, which is on its way, is the first leg of a sample return journey. So Perseverance will be collecting samples. It will be sealing them in these pristine, biologically clean tubes. And then a future mission called the sample return mission. It doesn't have a fancy name yet.
Yeah.
So that will go and collect all the samples from the surface, put them on a Mars ascent vehicle, send them into orbit for rendezvous with a carrier spacecraft, and then that carrier spacecraft will return. And you will be able to do with those samples back here on Earth with your very sophisticated laboratory equipment. Even though Perseverance and all the rovers have had good science instruments, nothing compares to the buildings and buildings of fancy, good high-tech equipment that you can do science with here back on Earth. And those samples will be invaluable in really understanding, what the conditions on Mars were as far as life and the possibility of that it was somewhere else in the solar system. So it's all exciting and all coming up ahead, and it's just the first leg.
Okay, so let's delve into the helicopter a little bit further. You're the chief engineer on the project, and how many team members do you have that have worked on this with you?
Oh, I think at the peak level, we were probably had about 60 or 70 people, full-time equivalents, when we were right in the major build phases.
Mm-hmm.
Right now, our operations team is probably down to more like about 10 that'll actually are getting ready to develop all the command sequences and do all the rehearsals and practice all the particulars that we will be doing during those 30 days. Yes, so it's been anywhere from peak of about 60 to 10. But when I say 60, you should also remember that many of those people were part-time. So we have had various people in all sorts of technical disciplines, not only at the JPL, but we had significant participation from the other NASA centers and from industry that were all involved in building this vehicle.
Okay, great. So tell us a little bit about the challenge of designing a helicopter that will fly in an atmosphere that's just 1% of the density of Earth. And let's start with the speed. I mean, are the rotors running similar to what you might see here on Earth?
No, they actually spin much faster. Really, you have to move the air in order to get that thrust and lift going. So the way we do it is we spin the blades very fast, but there is a limit to that. We don't want to get close to the speed of sound at the tip blades because that starts affecting the aerodynamics in more unpredictable ways. So we have a relatively conservative posture on the blade tip speeds. We go to about Mach 0.7, 7/10 the speed of sound. But that still means that our 1.2 meter diameter blade spins at about 2,400 RPM that's 40 times a second in order to bite into the Martian air and generate that lift. So that's been sort of the dominant challenge, but there have been other engineering challenges. First of all, in order to fly, you want to make this thing as light as possible, because otherwise you just won't be able to take off. But at the same time, this very lightweight, almost gossamer-like aircraft has to survive all the rigors of getting to Mars. So it has to be a spacecraft too. It has to survive launch loads, launch vibrations. It has to survive the vacuum of space, the radiation environment of space. Mars gets extremely cold. We expect to get to minus 90 degrees centigrade at night. So you have the challenge of not only building a first of a kind aircraft that would enable powered flight, but it also has to be a very durable spacecraft that can get there and function. So there's two aspects to this challenge that are quite unusual.
Got it. Okay. So the speed limit of the tip of the rotor at 0.7 Mach, that kind of sets an upper limit to how heavy your helicopter can be,
Correct.
essentially, right?
Yes, we had a certain limited amount of space that was available on Perseverance to allow us to conduct this technology experiment. So that basically set the blade diameter. So you look at the blade diameter and you see how much air can move through that swept volume of those blades, and then
Right.
you have this constraint on the tip speed, and essentially end up knowing that you can't be more than about 2 kilograms because you want to preserve enough thrust margin and so forth. And we ended up at 1.8 kilograms, not 1.8 tons or 2.5 tons like NISAR, but 1.8 kilograms.
Okay. So what can you do with 1.8 kilograms on Mars? You put a camera on it, I guess.
Well, primarily, this is a technology demonstration that is returning engineering data. We have done all the simulations, all the testing here in Earth chambers to prove that this would work. And we are fairly confident that we've got all that right. But the real proof is to actually go to Mars and fly. And it's very similar to the little Sojourner rover that in the 1990s demonstrated that roving was a good idea, a good feasible idea, and that paved the way for the Spirit and Opportunity and Curiosity and now Perseverance. So the whole focus is on returning engineering data. How well did the aerodynamic systems, the rotors perform? How well did the navigation perform? And so just look essentially to validate the design. And once we have that in hand, we can then go about designing larger, more science-oriented helicopters for Mars. Ingenuity, which is the name of this little helicopter, is only equipped with a small color camera, very much like what you have on your cell phone. And that's just so that we can return some images, which will be kind of cool. But there is no science in no science objectives. It's all related to getting an engineering performance evaluation of the system.
Okay, and let's talk a little bit about how this aircraft will fly. So the drones that we operate on Earth, the unmanned vehicles, can typically be controlled by a pilot or an operator of some kind, sitting at some base, somewhere on Earth. Signal, of course, radio and light signals take quite a bit of time to get to Mars and back. So is the rover controlling the device or software controlling it? Just tell us a little bit about how this will operate.
Yes, so the helicopter itself is designed to be fully autonomous. All it's expecting from Earth is a sequence of waypoints in the sky. So basically go from point here to here to here, and then the helicopter will fly through that trajectory specified by those waypoints in the sky. It's basically an XYZ heading type of specification. So the way we get those commands to the helicopter is we have a base station unit that's hosted on the rover, which serves as a relay between the commands that are generated on Earth by our operations team. They get radiated by the Deep Space Network to the Mars orbiters typically, and then the Mars orbiters will downlink those commands into the Perseverance rover. And then the Perseverance rover uses this base station as a relay to get those commands out there and then get the telemetry back, and then the telemetry follows the return path all the way back to Earth. So as far as the rover is concerned, we just look like yet another science instrument. There is a standard instrument interface that we conform to. Commands come in and they mysteriously get radioed, to the helicopter, if you will. The rover itself is completely unaware that it's got a helicopter. It just thinks that there's an instrument on board that's just behaving like any other instrument. And we have a radio link, obviously, between the space station that stays fixed on the rover and the helicopter itself. And that actually completes that last leg of that telecommunications. And
And
not
what's
only
the
do we
data
have,
rate? Sorry,
go
go ahead.
go ahead.
What is the data rate you're able to achieve between Mars and Earth?
Oh, it's a few hundred megabits per day is probably the the limit. It really depends on the orbiter passes and what a lot of the data will also be taken over by other engineering functions on the rover. But during this 30 days, so we expect to get most of the available bandwidth, and it's in the order of many hundreds of megabits per day.
Got it. Okay. The helicopter will detach itself from the belly of the rover and then make its first flight. How is it powered? Is it using solar panels, or do you have a nuclear battery on it? Or
Right. So on the way to Mars, we are actually depending on the rover itself to provide us the electrical charge and the electrical to keep our batteries topped up. So we actually have an umbilical line that comes right into the helicopter. And in fact, we have, every 2 weeks or so, we just top up the battery a little bit. But once we are on the Martian surface and detached, that electrical line is no longer available. Communication is to a radio link at that point. But then once the rover departs, it drops us on the ground and it departs, our solar panel gets exposed and we charge up our batteries using our own solar panel.
and at night, what happens to the helicopter? Is it does it land anywhere it feels like, or does it come back to the rover, or what?
No, we're very deliberately staying as far from the rover as is safe. So the rover will be about 100 meters away anytime we fly. And so we have a plan to designate a certain airfield, if you will, on Mars, that this being a technology demonstration, we want to make sure that we have a very safe area to take off and land. And so there'll be a nicely pre-surveyed airfield and landing pad. And we will do all the flights, test flights from that landing pad airfield area. And when we come back and land during the night, the only thing we are doing is basically running a bunch of electric heaters to keep ourselves warm through the Martian cold. And so we, especially the batteries, we try to keep them, at a comfortable temperature, as well as some of the electronics which are derived from, commercial parts. So that's heater activity at night and a short, up to perhaps 2-3 minute flights at most, but usually 90-second flights, during the course of the day.
Wonderful. Thank you. Thank you so much. So if there's a young student at one of the IITs today, like you were at IIT Madras many years ago, tell us which hostel you were in, Bob.
Ganga Hostel.
Oh, the Ganga hostel. Okay, so imagine there's a young kid, in the hostel room that you stayed in Ganga hostel, and he or it would be a he if it's the boys' hostel, but let's generalize it. A he or she, as a student, is thinking about what they want to do. Having been inspired by General James' talk and your talk, uh, is it reasonable for them to aspire to figure out life on a planet on one of the moons of Saturn? Is it conceivable that we'll be sending, probes further out of our solar system? What should they be dreaming about? And perhaps if you can tell us about what you dreamt about as a student, that will kind of ground them.
Yeah, so let me start with my own inspiration. It was really the Apollo program. I had an uncle, my mother's brother, who was very interested in space, and he'd write to the local US consulate, and they would send these thick stacks, what I now realize are 8.5 by 11, glossies. We do A4 size in India, which had all these wonderful information about, the Gemini program and the Apollo program. And he used to get them, and I used to devour them as a little kid. And so when the moon landing happened, I listened to it on radio. Television hadn't quite penetrated to our neck of the woods there yet in India. And that was inspiring. And I think the really great thing now is that you have these global partnerships where there are a lot of people, whether it's for earth science or space science, there are opportunities now as a, collectively, which we didn't have before. The technology has come such a long way that a lot of the missions that you couldn't even conceive of, for example, the helicopter would not have been possible 20 years ago with the technology back then. So both the technologies, the ecosystem of companies and opportunities is so much vaster now than before that I think any kid in India can definitely follow their dream, whether it be earth science or space science or building things or operating things. I think it's wide open right now compared to what all of us had, 40 years ago.
Right. I think all three of us here are about the same age, and I can certainly remember when I was in middle school and high school. My father was a professor, and we used to receive this tremendous amount of information from what was called the U.S. Information Service, USIS.
Yes.
There was a magazine called the American Reporter and another one called the American Review, and every nuance of Gemini and Apollo and all of those missions was pouring into our mailboxes, our physical mailboxes for the young people on this call. We didn't have email back then. It's unfortunate, in fact, now that the United States doesn't have that kind of devoted effort to promote all of the good things that are happening in this country. And I mean, there are people right here in Southern California, I think, who don't really fully realize all the tremendous innovation happening right here at JPL. In fact, I was looking at the ISRO website to talk about the flip side of it, and I had trouble finding information about NISAR over there. So, in terms of marketing, I think there's something that, perhaps more of a cross-cultural marketing effort is needed. I did want to mention to the audience, though, there are a lot of technical questions that are coming up about both of these projects. And the JPL website is, it has a boatload of information. If you go to, I think, nisar.jpl.gov, you will find, more information than you can possibly absorb. And likewise, if you look at if you Google the term for the Mars helicopter or the Ingenuity, you will find tremendous bits of information. Even the name Ingenuity, Bob, can you tell us how that name came about?
Yes, it was NASA runs a contest typically to name the rover, and the rover got named by Perseverance by one of the kids who submitted a winning essay. But there was another essay by an Indian American girl called Rupa, and the NASA administrator said, you know what, this name Ingenuity and this essay is just perfect for this helicopter because perseverance to get us through this COVID and launch on time and get that done, most appropriate. And in some sense, the innovation and the sort of the sheer ingenuity that it took to build a helicopter. So both very appropriate names, and Ingenuity being selected by an Indian American young lady from high school in Alabama, I believe.
That's awesome. That's a great story. And again, a great story for this week when Time Magazine has just selected for the first time ever its Kid of the Year. And the Kid of the Year happens to be a young Indian American girl, Anjali Rao. So I think, Indian Americans are doing more than their fair share in terms of creativity, technology, and perhaps even a little bit of politics with Vice President-elect Kamala Harris. So these are good times for us, who were born in India and are now working here in the United States and working in these exciting fields. Larry, I have, you might have seen on the agenda, there were many sessions around data and data science and AI. So of course, people want to know how you're getting that 43 terabytes down to earth. And then is it being stored on Amazon Web Services or Microsoft Azure? And how are you processing it? All the tech heads want to know.
Yeah, well, first we get it down primarily by Ka-band link, so pretty high data rate coming down on Ka-band. And then we are using cloud services. I won't specify which ones, but this is really the first large scale data mission that we're using cloud services to manage all of this. So absolutely. And, in many ways, I have a mantra that I say, it's all about the data. If we don't get any of this data back from our missions. No matter how well we construct the spacecraft, then they're worthless. So you've got to get the data back, and ultimately you want to do science and discovery with that data. So we're very much focused on managing large data, applying analytics, applying AI, applying machine learning. We've got multiple areas across the lab that are focused on that.
Yesterday, we had the CEO of IBM, Arvind Krishna, who also happens to be a graduate of the Indian Institute of Technology at Kanpur. And he talked about how both AI and quantum computing are going to play a major role in the transformation of society within the next 10 years. Quantum computing as well is not something out there 20, 25 years out in the future. So it'll be exciting to see how the kind of data that you gather through NISAR will end up benefiting humanity through these new tools that are being developed to analyze and assimilate that data.
And John, I'll just say on quantum communication as well, which is important in terms of handling this data. We have some really world-leading technology at JPL on super cool nano photon detectors where you can detect single photons and start to do quantum communication with that. We have a partnership with Caltech, partnership with DOE here in the US, and a partnership with AT&T to help develop the quantum communication side of that as well.
Wow. So let's talk a little bit about the human challenges of doing this work. And I want to ask both of you about this. Let me start with General James. So, you went through a transformation from a military career to more of a scientific exploratory kind of role. So I'm sure that was an interesting situation when you are dealing with a bunch of PhDs, 6,000 of them, and I should mention to the audience that you're the chief operating officer of all of JPL. So, several thousand unruly PhDs, are under your care and management. And I can imagine, how difficult a job that would be. That the heads of the IITs manage a number of PhDs, but not as large as you do. So for the directors of the IITs, you're actually dealing with something far more complex. But I wanted to drill down about the cross-cultural challenges. You mentioned the time zone difference between the US and India, and obviously that's a challenge. But tell us a little bit more about, the cultural issues or the communication issues that might come up. And you can be frank, you're among friends.
Yeah. Well, I mean, again, as I said earlier, we all approach problems a little differently. And we certainly on the space side, JPL has a culture of how we think about and approach problems and building spacecraft. And, ISRO and IIT have a cultural approach to how they do it. And so those cultures are going to be different, but you kind of ultimately as engineers, we get together and we figure out, okay, what are the interfaces? How do we connect together? How do we do the verification and validation? It becomes kind of a large systems engineering problem with culture as a part of that. And so you kind of have to take the culture component into account as you put all of this together. But at least from a JPL's perspective, and I know from ISRO's perspective, you've got many, many international partnerships, just as JPL does. So it's not unique in terms of the process. It's just now we have to understand the culture and how X, Y, and Z does business here. How do you do verification and validation? How do you validate the interfaces? Oh, that's different than how we do it. Let's talk about how we write something down that brings those together successfully. So we've been very successful at that. I think our teams it takes time. It takes face-to-face meetings, really does. So our folks have traveled over there, your folks have traveled over here. But over time that gets built, confidence gets built, understanding gets built, and you press on. And now that we've done it, the next time around will be much easier.
Yes, absolutely. Yeah. So are there learnings there that you would share with other initiatives, maybe at other NASA labs or other government agencies? The future we see here in the next 10 years is that the US and India are going to be collaborating much more closely together. Certainly on the military front, relating to the threat posed by China, that both the US and India are recognizing, and the strategic collaboration. The State Department and the US Department of Defense now refer to that region as the Indo-Pacific region. They don't no longer say, Asia-Pacific. They've specifically added the word India, and that I think is a deliberate decision by, DOD as well as the Department of State. And I fully expect President-elect Biden to take up that terminology and take it forward. So are there lessons that you would, if you were talking to somebody at state or at defense, and we're going to be working a lot more with the Indians, what are the top 1 or 2 tips that you might share with them?
Yeah. Well, again, first let me say that NASA has an Office of Interagency and International Relations, OIIR, and I feed back into them whenever I'm in India. I'll write up a trip report and say, here's how we did things, here's what happened, and that gets kind of captured and promulgated throughout NASA as required. So that's a good point in terms of making sure that the word gets out within NASA. But I think just like any international relationship, if I was to talk to my friends in the DoD, and frankly, when I was in the Department of Defense, I was trying to build relationships with India, but it was a little harder back then. This was the early 2000s and time frame and mid 2000s. Yeah. So it just was not as easy. Sure. But number 1 is patience. You just have to recognize that it takes time to build the relationship and to build the trust. And number 2, recognize that there will always be a different approach in terms of how you do things. Sure. I think we're amazed at how quickly Israel builds a satellite bus. You just have a great process, and I've been in all of your facilities over there, and frankly, they're a lot better than ours in many ways because ours are much older. You have a very nice flow of your equipment through the test facilities. We have to move our equipment all over the lab because they kind of grew up over the years and they weren't really designed to flow well. Right. So those are the types of things that you just have to make sure as you go into a relationship, patience, build relationships, recognize that the processes will be different, but then you figure out how to work together.
Thank you. And Bob, same question to you. You've worked with a team of 60 people on the ground at JPL. Many of them come from, different nationalities and cultures, and I'm sure from different disciplines because of the amazing complexity of this project. So when you have a material scientist arguing with a, fluid mechanics expert, and they both know more about that subject than anybody else, on the planet, and they're both right, how do you deal with that as a chief engineer?
Yeah, so one thing I must give credit to my IIT training. I know what I know and I know what I don't know. And that is a very important thing to have in your head. So specific to, putting together something like Ingenuity was having a very clearly defined goal does wonders for focusing the mind. Having a very clearly defined goal that has a very definite deadline, we got to get on perseverance, otherwise you're not going to get this thing done. That also wonderfully focuses the mind. Mm-hmm. And I think it does the same thing for the team. So I think that was the 2 key enablers, that we had a very clear objective and we had a very clear timeline. And then, yes, it was a very adventurous path with many a twist and turn and many test failure and, success. But having that kind of focus, I think, lets people, regardless of, their differences and their differences in practices and cultures and styles and all of that, it allows everybody to move ahead to that common goal in a time frame that's not too long, because sometimes having a too long a time frame tends to, dissipate energy. So I think those were key elements, I think, that helped us get to where we are right now.
Great. So one thing I just wanted to highlight that you mentioned in your conversation was the deep space network. So this is, if I understand correctly, a set of satellite communication ground-based devices all across the globe that are run by NASA, right? Right. And the deep space network, for those listening in from India, was a key component of the success of India's Mangalyaan mission. When India launched the probe to Mars, there was a lot of pride in India about how this was, a dramatic success, which it was. But Indian media really did not report very much that the mission wouldn't have gone too far without the support of the Deep Space Network, because once the device left the, the region of the Earth, the only way for it to get to know where it was through NASA's Deep Space Network. Am I paraphrasing that correctly, gentlemen?
Yes, absolutely. I mean, we had a long-term agreement with ISRO to support that mission. And as you said, in general, once you get past geosynchronous orbit beyond the moon, the Deep Space Network is the only globally covered network out there. We have sites in the Mojave Desert in California, Canberra, Australia, and Madrid, Spain. So you essentially get that 360 degrees of coverage, so you can talk to your spacecraft anytime you need to. And so, yes, we had an agreement with ISRO to support that, both for communication and navigation, just like, we're supporting our current Perseverance mission on the way to Mars. It was doing the same thing for ISRO. And I can't remember if ISRO has a site in India that could communicate with Mom, but at least with the DSN, you had the full Earth coverage that allowed the mission to operate.
Got it. Well, there's a question here from my classmate from Kanpur, Christopher Flores, and he wants to know whether either of you see a role for manned missions to Mars, or is unmanned the way to go for economic and political reasons? And we know what Elon Musk's answer to that is. We'd like to know your answer.
So what we are doing, opens up that aerial dimension to Mars in terms of exploration, but we don't anticipate that you'll ever have large helicopters in Mars. The largest we consider is maybe in the 20 to 30 kilogram range is probably what's reasonable, just given size and other issues. So we could be a good adjunct to any human exploration if and when it happens, but we're not directly in that business of flying somebody around Mars.
But Gunjan, I will say that NASA does have the Moon to Mars program, right? So the first component of that is the Artemis program, getting astronauts to the moon, understanding how we do that efficiently and well. And then there's already work going on with respect to the biological nature of how do you get astronauts safely to Mars in a radiation environment and those sorts of things that we have to think about when you have humans on board. So, NASA has a goal right now, broadly speaking, of, getting humans to Mars in the early 2030s. That could be getting to Mars and just orbiting on the first mission, then subsequent missions land. So that is absolutely a part of the strategy of NASA itself. And as Bob said, we're not in the human side of the business per se, but we provide a lot of support. We do a lot of the precursor missions. You go back to Apollo, JPL landed the surveyors, built and landed the surveyors on the moon to understand the environment before we send astronauts there. Now we've done the same thing with Mars, so they can understand what it's like when the astronauts get there. So we do a lot of the precursor work that allow the humans to go forward.
General James, is there something else you would like the audience to know that we haven't covered yet? There's so much material we had discussed, so I want to be sure that we didn't miss out anything that you consider important.
No, I think we've covered everything, but I would just say that we value the ISRO partnership very, very highly. It has been very successful, and as I said, allowing us to conduct the NISAR development and ultimately operate the mission. And we truly do look forward to many future endeavors. I didn't talk about airborne missions that we've flown together with, visual and IR sensors over India and over the US. I mean, there's a lot of things going on beneath the surface, if you will, but it's a highly valued relationship. Frankly, India and the US are two of the key spacefaring nations, especially democratic nations, and we want to see that future continue to grow.
Awesome. Bob, anything that you'd like to share that, any highlights that we didn't get to? Oh, we haven't shown a picture of the helicopter. Let me do that. Yeah, very important. Sorry.
So while you bring that up, Gunjan, I just wanted to say that, yes, we are landing in February, and approximately 2 months after landing, when the rover is fully commissioned, they will find a spot and drop us off, and then we should have a very exciting 30 days. So please come back in the summertime and see what we're up to.
Yeah, great. So when the landing happens, when the rover lands, that's in February, right?
Yes, February 18th, I believe.
Okay. At that point, the Ingenuity will just stay at the bottom of in the belly of the rover. And what will it be doing? Will it be warming up or?
No, it's basically the first so many weeks is getting all the rover systems. The rover at that point has to transition from having been an interplanetary spacecraft to a on-surface mobility system. So there's new software loads and checking and commissioning and checkout of various, just driving, cameras, the whole thing. So once they get everything out of, fully commissioned, they will start driving and find us a landing pad, airfield area. Then they will drop us off from the bottom of the rover, go to a good standoff distance, like I mentioned, and then we'll start our experiment.
Okay. Is there any particular slide you want me to focus on here?
No, I think that's a good picture of that's the artist's conception. And if you go to the next one, that's the actual unit that's on its way to Mars right now.
That's the actual unit. Wow. Oh, I understand what you mean by gossamer thin. Yeah. Wow. Amazing. So these are carbon fiber blades?
Yes,
and
carbon fiber blades, and there's the solar panel on the top, and right in the middle of the solar panel, you can see a little antenna sticking out.
Yeah, this one?
Yeah. These are counter-rotating blades, so that basically torque canceled. And just at each of the blades has a propulsion motor and servo motors that control the blade pitch. And below the blade's rotor system, you have a fuselage box, which is basically where the batteries and the electronics are. And down below on the bottom of the box, you actually have viewports for laser altimeter and camera to look at the ground. And then you have the 4 landing legs. So that is the way it's all set up. And we're all folded up and tucked in under the rover right now. But there will be a unfold and deployment operation, after about 2 months. And that's when we get deposited on the surface. And at that point, we should look like the earlier picture that you showed, where that's what it should look like on Mars. And just a few days ago, we actually did some dress rehearsal dry runs with a clone mock-up of the helicopter as well as the ground test bed for the rover. So we actually have been rehearsing the drop sequences just over the last few days. So it's all coming together, both in space and us getting ready to do the mission.
So do you have a vacuum chamber here at JPL where you test this?
Yeah, so all of this system was tested in vacuum chambers, which basically allowed us to pump down the vacuum, backfill with carbon dioxide to the Mars pressures, and then validate and test all our flight dynamics that we could fly, we could control. We also had other chambers that we took this into where we subjected it to cold temperatures and vibration and shock testing. And then we also did a bunch of integrated testing where the rover folks with us on board, with the final flight units of everybody, went through a week-long campaign of what the surface mission would look like. And we were deposited at Mars temperatures onto the surface of the chamber. So everything's been tested in some other test facilities. And now it's time to test in the real environment.
Okay, great. I think we are waiting for our host to come back and round up. Let me try and ask a couple of challenging questions while we wait for them. So both of your missions have some degree of risk, right? So General James, you're spending $1 billion+ sending this one satellite up. I remember that movie, Contact, where the whole thing blows up on the launch pad, but the Japanese have built a second one that they didn't tell anyone about, and all of a sudden they have a solution. What is your recourse in case something goes wrong?
Well, I mean, there's various varieties of what can go wrong. A lot of times something can go wrong that we can fix with software, for example, or new ways of operating. So that's part one. If you have a major failure, I mean, an example for us was our orbiting carbon observatory spacecraft, the first one we built, the upper stage failed and we didn't get to orbit. And so NASA chose to invest in the new satellite, orbiting carbon observatory 2, which is currently operating. So, it just depends.
Yeah. Bob, will you have sleepless nights starting February?
Oh, no, my sleepless night started 7 years ago when this project started. No, we are a technology demonstration that fits the phrase, high risk, high reward. So we are recognized to have a risk posture that is not a flagship mission. We are meant to be this groundbreaking, pathfinding sort of animal that will check it out. And so we have done everything on our end with earth testing and managing the risks that we have a pretty good chance of succeeding. Not to say that there couldn't be a glitch. We are pushing the limits of some other technologies. But JPL's motto is to dare mighty things, and I think in a small way, our helicopter is one element of that. Sending up these wonderful Earth observing systems is another, aspect of that. And so you can't let that hobble your thinking. You have to move ahead and keep and do the right engineering to minimize and manage all the risks.
Terrific, terrific. Well, General James, thank you so much for taking time, with us today. Dr. Bob Balaram, really appreciate you doing this session today. I'm sure the audience has enjoyed this very much, and they have recorded it. So people, it's past midnight in India right now. So some of them who cannot join live will be able to view this, later on. We very much appreciate both of your time today, and I will be watching closely in February to see what happens with the Perseverance mission, and then in 2023 what happens with NISAR. These are both really exciting initiatives and a great way to showcase Southern California as well, where all three of us live. So thank you very much, gentlemen.
Thank you, Gunjan. Appreciate the opportunity.
Thank you, Gunjan.
Yeah, bye-bye now.
Bye.